Hello everybody, I will start my today's coding practice. So today's question is this one, code schedule 2. So in this question, I will be given a variable num_courses, which represents the number of all the courses. And also I will be given prerequisite, which represents which is the array of list of list. And each list represents a prerequisite of specific course. So, I mean, prerequisite AB indicates that I have to take course B first if I want to take A. For example, 01, I have to take course 1 first and then course 0. I can take course 0. And my task in this question is return the ordering of courses I should take to finish all courses. If there are many valid answers, return any of them. If it is impossible to finish all courses, return an empty array. Okay, so my intuition is that I can use the topological sort in this question. And let me explain what the topological sort is for real quick. So, when I'm given the nodes, like the graph, then I will be given, and my task is find the valid order to visit all the nodes in that graph. And I will be also given the constraint. Like, if I write to visit node A, I have to visit node B first. For node C, I have to visit node D first. And under such constraints, I will find the valid order of the nodes I visit, which satisfies all the constraints. So simply saying, this question is a kind of question which I can use the topological sort exactly as it is. Yeah. So that being said, let me explain how I can implement the topological sort. So for this example, this input suggests that there are 4 courses 0, 1, 2, 3 because they're 0 indexed. No, no, oh, no. 0. Yeah. 0 to n minus 1. Yeah. So in this case, 0, 1, 2, 3. And also I will be given this array which suggests I have to take course 0 before course 1, course 0 before course 2, and course 1 before 3, 2 before 3. And that being said, I will think of the order in which I will visit all the nodes or the courses satisfying these 4 constraints. However, I just have to take care that I don't necessarily have to take course 1 immediately after course 0. It can be 0, 1, 2. Yeah. In that case, course 2 is not immediately after course 0, but still it's after 0, so it's okay. Okay, so that being said, let me tell you how I can answer this question. So in this type of topological sort, I will think of the in degrees of each node. So in degrees is how many edges come into that node. Yeah. So that number is in degree for each node. So in this case, for node 0, there isn't any node which, direct into this node 0. So it should be 0. For 1, there is, one edge which comes into the node 0. Sorry, node 1, this should be 1. And for node 2, there is one edge which is 0, 2. And for node 3, there is 2 edges, 1, 3, and 2, 3. Yeah, so this is in degrees. And what I can say is, if in degrees is 0, I can take that course because there's no prerequisite anymore for that course. So in this case, this can be taken. So I will first take node code 0. Then what happens if I take code 0? Because code 0 has an edge which goes to 1 and also that which goes to 2. So which means that for this node 1, I mean code 1, I can decrement the in degrees. Yeah. More specifically saying, I can think in degrees is, in this question, number of courses I have to take before that course, but which I haven't taken. So in that definition, yeah. Now course 1 has only 0 requisite, and the same for course 2. I can say because course 1 is already taken, the in degrees is decremented by 1 and now it becomes 0. So now what I can say is I will focus on node 1 because course 1 is taken. I mean, it can be taken, I will take it. Then what happens is if I take node course 1, I can take course 3 now. I mean, take one of the prerequisites of course 3 is met. So this in degree of 3 is decremented by 1. Then after that, I will take a look at course 2, which I can take now. So I will take it. Then with edge 2 to 3, I can say code 3, one of the prerequisites of code 3 is now taken, finished. So I can decrement the prerequisite of code 0, no, code 3. And now I can take code 3 because the remaining prerequisite is 0. So this is the basic idea of topological sort. So let me quickly summarize it. So I will use the in degrees hash map. And also I need the adjacency list because as I did when I take code 0, I'd like to know which courses, which courses have this code 0 as the requisite. I'd like to know all those courses and decrement in degrees by 1. So that's why I need adjacency list. And also, I think I need... Yeah, I think that's what I need. Oh, and one more thing is, I can say, if I do this topological sort, and if there is... if I find that I cannot visit node anymore, it means that there is a cyclic dependency. The most simple case is like this. 0, 1, and 1, 2, 1, 0. So in this case, in degrees is something like 0 to 1 and 1 to 2. Sorry. 0 to 1 and 1 to 0. So 1 to 1. And from here, I can see there is no course which has 0 in degree, which means 0 prerequisite. So I cannot even start. So which means that I cannot finish all the courses. So in this case, there is a cycle. So I will return the empty array. It can happen in the middle of the topological sort. Like I visit 3 nodes, but after that I can't find any node I can visit, which means that integrity is 0. Yeah. Okay, so this is the basic idea of topological sort. So let me get started with the implementation. So firstly, I will initiate adjacency list and integrate from the given prerequisite list. I will do the implementation later. Let me say orders here. Then what I will do is, I will put the takeable courses in this stack, and first 3 takeable courses are courses whose in degree is already 0. So let me check it. Okay, so in this way, I will take all the courses whose in degree is currently 0, and these are takeable. And while there is a takeable courses, I will take that course. And because I will return the array, courses in order, I will push it into this array. And also what I can do is decrement the number of in degrees which have this current as the prerequisite. So let me use adjacent arrays here. Or and because for these adjacent courses, I will decrement in degrees. And as I said, if in degree is 0, it means that that course is now takeable. Or let me call it takeables. Okay. Yeah, that's it. Then finally, when I find that there is no course I can take anymore, I will return the return array. However, if return array is less than num courses, which was given, it means that I couldn't visit all the courses. So in that case, I will return an empty array. this is it. Let me quickly confirm my code again. I will get adjacent. I will build adjacency arrays and increase hash map first in line 34. Then in line 35, I initiate the takeables stack, which includes courses whose prerequisite is 0. Okay. Then from line 38, I will start the topological sort. So I will pick one takeable course in line 39 and I push it into the returned array because now its code is takeable and I will take it. Then after that, if there is a course which requires current course as a prerequisite, I will decrement that courses in degree in line 43. Then, if the in degree has become 0, which means that now I can take that course, so I push the next course, that course into the takeable stack. And in line 47, after finishing those iterations, I will return the array. Yeah, if I could take all the courses, otherwise return empty array. Good. Okay, so I will implement build adjacency arrays. So. And in this case, I have to take B2 before B1, so the order is in this order, right? Yes, so now in this case, in degrees of B1 is incremented. And also for our appended is the adjacency resource. Then I will return adjacency list and in degrees. Okay. Let me check it again. I initiate adjacency list and integrate list. Then for each order, because I have to visit V2 and then V1, I will append V2, V1 to adjacency list, and also in degree of V1 should be incremented by 1. Okay, good. I will submit my code. I see. So it failed. Seems like length of return is okay. So seems like empty array is returned somehow. Let me think. So in this case, there are 2 courses and prerequisite is 1, 0. It should be 0 to 1. Yes. But in my case, I return length 0. So what I can do first is check what adjacency arrays increase hash map and takeables are created from this input. So for adjacency arrays, what is created is node 0 has node 1 as in adjacent node, and also I will have I get the hash map of in degrees, which seems to be correct. And now takeables as code 0 as element. which is correct because I can take cos 0 first. Yeah. So in line 40, length of takeables is now more than 0. So now in line 41, I will pop out 0 from the takeable stack and I get 0. And append 0 to the returned array. Seems like correct. I don't know why return is empty. Oh. So it seems like code 0 is appended to the returned array. However, code 1 is not. So let me take a look. For in line 44, I will take a look adjacent series, all the adjacent codes, and I will decrement the degrees. Yes. And if in degrees of the next code has become 0, I will append the next code into the takeables code. Yes. So now takeables code has code 1. Then I go back to line 40, 41, and current is popped out from the takeables code and appended into return list. I have no idea why 1 is not in the returned array. And takeables and next code. Oh, wait. Sorry, so in line 46, I should decrement by 1. Okay. I'm pretty sure of this, so let me execute my code again. Good, I will submit it. Okay, good. So now my solution is accepted. So let me do the complexity analysis. So for time complexity, firstly, I built the adjacency list and integers list. So assuming that there are V again, num causes is n. So let me assume there are V causes and E prerequisites relationships. Let me see. So firstly, to build the adjacency list, I take a look at each, prerequisite. So it will take, oh, sorry. And also in line 54, I initiated the integers hashmap with n. So it should currently, it has taken V plus E time. Then in the topological sort, in line 41, I can say at max, every course is pushed into the takeables codes, no stack, and popped out from the takeables stack. So this part in line 41 takes v times. Yeah. And also I can say in line 45, I took a look of all the adjacencies of the current node. And as I said, current node is popped out exactly once. So this line 45 appears exactly once for each unique current node, which means that each vertices, each edge, the prerequisite relationship is seen only once. So I can say what I mean by in total is this in total, in line 41 I use the while loop, and I consider all the iteration step of that while loop, and considering that the total times of line 45 is b plus e. And after that, in line 46 to 48, it takes only the constant time. So I can say the time complexity is b plus e by summing up this, v and e. And for space complexity, adjacency risk can have at max v edges, and also for in degrees, because it's a key value pair and the key should be each node, so it should be for adjacency risk it should be e. And then in line, but actually adjacency risk is finally becomes v plus e, because I use default dict. So firstly, the key for each node is not necessarily created, but in line 46, I check the adjacency node of every node. Adjacency node of every current node. So at that moment, new keys are created, which means new nodes. So finally, number of keys should be exactly the number of nodes, and the total number of element in the values should be number of edges. So in total, it should be v plus e. Then I will come back to the main method, and only data structure I need is, aside from the return array, is takeables. So it will be up to v number of causes. So by summing up, it will be v plus e space complexity. Let me quickly confirm in the tutorial. Okay, seems correct. Good. So I will quickly wrap up today's practice. So today I solved the question course schedule 2, in which I had to use the topological sort. And this is a quite basic question for topological sort. So what I did is exactly the topological sort only. And for topological sort, I firstly initiated the in degrees hash map. This suggests how many prerequisites each course has. And also I initiated the adjacency list. which represent for each course what are the courses which require the current course as the prerequisite. So with these integers and adjacency list, I started the iteration. And I put all the takeable courses into the stack. Yeah. I initiated the stack and I started the iteration. So if the course is takeable, I take that course. Then I will think of the, courses which requires that course as the prerequisite. For those courses, I can decrement the integers by 1. And then at the moment when the integer becomes 0, it means that that course is now takeable. So I put it into the, I push it into the takeable stack. Then I will continue the iteration. And finally, I return the return array, which stores the courses in the valid order. If I can take all the courses. Okay, so let me finish with this. Okay, bye.